Suppose that the house we want costs $300,000 after down payment. We've got an APR of 3.875%, and we're doing a 30-year fixed rate mortgage. A lot of what we're going to do in this, though, could certainly be applied to shorter term mortgages, whether they're fixed or adjustable rate, and even a long-term mortgage that's adjustable rate. So we're just introducing some functions that'll help us figure out, in the middle of the loan, how much we still owe, how much equity we've built, and how much we've paid in interest. So we start off the way that we usually do. We'll go into Apps, Finance, and then look at the Tvm Solver. So for this, we're going to say, well, okay, we might intend to move in 10 years, but the bank gave us a 30-year mortgage. So as far as N is concerned, our payments are going to be figured out over the course of those 30 years. So 30 times 12, our interest is 3.875. Remember that even though we pay on a monthly basis, that interest is, we're going to use the APR, the annual rate. Our present value, so this is how much we basically got the original loan for. So this is the 300,000. Whoops, a few too many zeros. So this is the 300,000. Our future value should be 0 because we're going to pay that loan down to 0. And then if we solve for payment, PMT, that'll give us our monthly payment on the house. So for this, our mortgage payment every month is $1,410.71. So that's kind of a standard piece that we've probably done up until this point. Now, we kind of want to break this down, though, and say, well, okay, after 10 years, what's going on? So great, that's a monthly payment, but what's going on? We do have to fill all of this information in before we can use the other functions that allow us to figure out the answers to these different pieces. So if we go back to Apps and then enter on Finance again, we're going to see we're at the same place that we find the Tvm Solver. But if we scroll down a little bit, we're going to see some other functions down here. So we see a lot of different, TVM things, but we're going to look at 3 functions in particular. So that's balance, the sum of the principal. So that's a sigma in front of PRN, and that just means the sum. And then same thing for interest. We see a little sigma and then INT, so sum of the interest. So these functions will help us figure out. So for example, the balance basically means what's our remaining balance after some number of payments. So how much do we still owe? Well, if we click balance, we want to say, all right, what's my balance after 10 years? Well, we don't want to say just 10 because we haven't made 10 payments. We've actually made 10 times 12. We've made really 120 payments. So if we check our balance there, it's going to give us this $235,348, and let's say we round, so this is going to be 41 cents. So this is still what we owe on the house, right? So balance, and you can do 120, or you can do 12 times 10. So we still owe quite a bit. Now, that doesn't mean that we've only paid about $65,000, right? We've actually paid more than that. So that the total money that we've paid has gone into equity and interest, right? Equity is money we've actually paid down toward the house. So there's a couple ways to figure this out as well. So one of them, we could say, well, originally the house was worth, well, our mortgage was for $300,000. If we have paid down $235,348.41, right, we could say, okay, here's going to be the number that we actually built in equity, essentially the amount of money we have officially paid down on this house. So this is one way to do it, is just by subtraction, and we would get 64,651.59. But another way to do this is to say, well, okay, what if we use one of our functions in the calculator? So if we go back to Apps and Finance, again, we scroll down, and from the list of functions that I mentioned, so balance was the first one, the sum of the principal was the next one. So this one's going to ask you for an entry. Now it's going to ask you for a start, or it's going to want a starting payment and ending payment. So we start from payment 1, and then we just say, comma, what's my last payment? So we could do the same thing we just did, 10 times 12, because we're going to be there for 10 years making monthly payments, or we know that that's 120. So the sum of the principal from 1 to 120, and if we do that, it's going to look negative because we're, again, just the direction of paying the money versus getting the money, right? The original loan was money given to us, so our payments are coming out of our pockets. So just the directionality here, but we see that we get the same exact number that I already wrote out. So 64,651 and 59 cents. So we can do, all right, I'm just going to say sum PRN, right? But that's really sigma, and of course we get that same number. Okay, and then we might also ask, well, how much should we pay in interest? So there's a couple ways to do this as well. We could say, well, how much should we pay in total? So total paid in 10 years, we could go back to our monthly payment. So if we just go back into the solver, we could say, oh, our monthly payment was $1,410 and 71 cents. So we could say, okay, we did that every month, and we're going to multiply that by 12 months a year, and we did this for 10 years before we decided we were going to move. So we could just calculate that, no problem. And I'm going to kind of cut to the chase. We know that there was 120 payments. So, okay, this is, again, it's a rounded answer, so we do want to be careful about that. When we round the monthly payment and then multiply it out, that rounding error is going to potentially put us off by a couple dollars when we're talking about numbers this large. So we might actually get something slightly different when we use the function. But assuming that our rounded value for monthly payment was correct, here's how much we paid in total. So we paid $169,000. Notice that we did not subtract $169,000 from the original loan amount, right? So a lot of that total payment went toward interest. Well, how much of it? So total paid in interest, we can say, well, if coming out of my pocket was $169,285.20, and some of that went to interest, some of it went to equity, we can take off the amount that went to equity, so $64,651 and 59 cents, and we can say, okay, this must be what I paid in interest, again, in 10 years, just to be clear. So let's come over here. So 169,285.20 minus 64,651.59. Okay, so it looks like we, in that first 10 years, we put $104,633 and 61 cents toward interest. So that's a lot of money, right? We've actually put more toward interest than we have toward equity, right? This is often what happens with mortgages. Is in the early going, you're paying a ton of interest and you're not really paying a whole lot down on the actual mortgage. So this is a good strategy would be to pay ahead on your mortgage so that you're cutting into that amount owed, building more equity quicker. Okay, but let's double check the function. So we had the balance function for part A. We had the sum of the principal to figure out equity in part B. And if we go back to apps, finance, and instead of going into the solver, again, we'll just kind of scroll down. And we saw earlier there was the sigma int, so the sum of the interest. So we're going to use that, sum interest, and we're going to figure out what that comes out to. Now, in theory, it should look like the 104,000 and change that we found, but I mentioned there was a rounding error, or we rounded the initial monthly payment, so it will probably be close, but not exactly the same. So let's check that out. If we do, let's choose that, and then just like for the principal, we have to give a starting payment and an ending payment. So we started on payment 1. 10 years later was payment 120, or 12 times 10. And we get a number that looks very similar to what we have, but notice it's just a little bit different. So it starts off very similar, 104,633. That part is the same, but instead of 61 cents, we would round, we get 76 cents here. So these two numbers very, very similar. And certainly if you're doing any online homework or submitting something online, there should be a little bit of tolerance in the answer to account for this slight difference. You should not get answers that are, thousands of dollars different. They should really only differ by maybe a couple dollars at this point.